All right, it's 7:02, so let's start the class. Share my screen. All right, so here we are. So today we're going to learn about committees and combinations. So basically what committees and combinations are is that one of the most important problems in counting is being able to count the number of ways to form a committee from a group of people or items. This type of problem is actually called a combination, and it's basically like a permutation, except order doesn't matter. So you saw in the permutations that we had to like sort them in orders based on different orders. Here we can just pick a random group of people and not have to worry about that. These pop up in many different areas of math and not just counting. A lot of algebra problems can be solved using committees and combinations too. So here we'll talk about forming committees. In these types of problems, you'll need to find a number of ways you can choose multiple items from a list. So how many ways can we choose a president, a secretary of the treasury, and secretary of state, and secretary of defense in a pool of 10 candidates? So here I have, basically there's a formula of doing this, but I'll show you how I usually do this using the permutations. So here we're basically picking 3 from 10. So we'll just draw the 3 spots here, 1, 2, 3, and we have 10 candidates. So the first spot has 10 possibilities. So I'll just do 10 here. And the second spot has 9 possibilities since we already used one. So we have 9 possibilities right here. And the third spot has 8 possibilities. And we just multiply these together. But the problem is, in this type of problem, the order doesn't matter because we're finding a group of people, not like we're not doing permutations, we're doing combinations. So um so what we need to do is we want to divide by the number of ways we can put those 3 people. So we do 10 times 9 times 8, and then we divide it by 3 factorial. So what we get is we're going to get 120. And it would be 720 if order did matter. So next we have choosing groups. So if we choose more than 2 items at once where order doesn't matter, we need to find out how many times we are overcounting by. We need to divide by the factorial of the number of items we are choosing. So usually if we choose 3 items where order doesn't matter, like in combinations, we should find the number of ways we can choose those. We can order those items and then divide it by 3 factorial. And if we chose 4, we would do 4 factorial and 5 factorial and so on and so forth. So in how many ways can 4 people be chosen from a group of 8 people? So here we're going to start with the permutations thing again. So I'm going to do this like I'm going to draw 4 spots, 1, 2, 3, 4, and we're going to find the number of ways we can multiply these together. So 8, 7, 6, and 5. We just do this, but since order doesn't matter here, we divide it by the number of times we can order these 4 people. So we divide it by 4 factorial, and what we'll end up getting is what we'll end up getting is 7 times 2 times 5, which is 70. So there's 70 ways to pick 4 people from a group of 8. We can also write this like picking 4 from a group of 8 as this, where the top number, you see these big parentheses, the top number is going to be the number of things we have available, and the bottom number is the number of things we can pick from n. So yeah, this is something that you'll see a lot in math competitions. It'll also be something you'll use a lot in these math problems. So I have 3 exercises of choosing people from groups. Yeah, Alex, can you say what you want?
For the factorial thing with the parentheses and things, like, can you go over it again? Like, the top number is it for like factorials or
Oh yeah, so for the parentheses, the top number is, so we're picking 4 people from a group of 8, right? So
yeah?
8 is like the number we have in the group. So 8 would be the top number. And 4 is the number we're picking from that group. So 4 would be the bottom number. So n is like the number of people we have, and r is the number of people we're picking out from the group.
Okay, so is this like a factorial or thing?
It's not a factorial, it's just a different way of writing this type of problem.
Okay, um, so does that mean like it's kind of like a fraction without a bar?
Well, it's not a fraction, but like it's just a different way. It's like we're basically just writing it like that, so it just makes it easier to just like choose this sort of thing.
Okay, that makes sense.
All right.
8 choose 4. So how many ways can you choose 4 out of 8?
Yeah. So I'll just have these 3 practice problems. I'll give you a few moments to do these. All right, let me just go over the first two. So these aren't the same questions since the first one, since we're picking a president, a vice president, and a treasurer, this one has order matters because all these positions are different. But in the second one, we're just picking a group of 10 people. So that means it's different. And the order doesn't matter in the second problem. So I'll just go over it now. So the first thing that we're going to do is we're going to do problem 1. So how many ways can I choose a president, vice president, and a treasurer in a group of 10 people? So we're going to do this the old way we learned how to do. We're just going to pick 3 spots and then pick the number of possibilities for each spot. So we've done this multiple times, but it's 10 times 9 times 8, which is equal to 720. Now, how many ways can I choose a group of 3 people from 10 people? So this one's different because order doesn't matter. And so the number of possibilities is going to be smaller than the one in the first problem. So we're going to just do the same thing. So we can also write this as 10-3 as we learned on the last slide. So what we're going to do is we're going to find the positions first. So we already have the number 720, but now we know that order doesn't matter. So we had to divide by the number of ways we can order the 3 people. So we do 720 divided by 3 factorial. And what we get is 120. So the second problem is 120.
That doesn't really make sense to me.
Why?
Because when order matters, oh yeah, there are like more ways that you can be chosen. But when order doesn't matter, so when order doesn't matter, when order matters, ABC is not going to be equal to CBA or something. So there are more things. But when order doesn't matter, so both of them are the same.
Yeah. Yeah. Yeah, you're right. That's how it works. So now let's do the third one. So in my state's lottery, 40 balls are numbered from 1 to 40 and 6 of them are chosen. So how many sets of winning numbers are there? So this one is basically the same concept as like picking a number of people from in a group, but there's just more intensive numbers and it might take a bit longer to figure out. So we're just gonna find the number of spots again. So we're gonna draw 6 spots. And we should know the numbers by now: 40, 39, 38, 37, 36, 35. We multiply these all together. But now since we have these 6 numbers and order doesn't matter, we just have to divide it by the number of ways we can order these 6. So we divide this by 6 factorial. And the answer to this one is 3,838,380. 3,838,300. So yeah, that's the answer to the third one. Now let's move on. So I think I taught you this already, but choosing k people from a group of n people, we can write this as nk. So choosing k from n. It doesn't have to be just people. N and k can also represent any items. And so yeah, since I didn't know how to format this in PDF, the problems are all going to show up like this. So I'll just rewrite this as the way it's supposed to be. So 4 from 11. So I'll just demonstrate how to do this. So I have multiple ways of, oh yeah, Alex.
So for the parentheses thingy, I think I kind of get it now. So for 11 and on the top and 4 on the bottom, it's a little like the factorials. So like you pick the first of four, you multiply the first of four numbers of like 11 factorial, and then stop there.
Yeah, like that. And then you divide it. So yeah, that's basically what it is.
And then you divide it by the factorial of the number that of spaces that you want.
Yeah. Yeah,
Like
that's what it is.
if you want 5 spaces, then you should divide it by 5 factorial.
Mm-hmm. Yeah, that's right. So I'm going to pick 4 from 11 now. So there are multiple ways of doing this. I'll do the one way, and then there's a formula for this. So for the first one, we'll just do the spots thing again. I'll just choose 4 spots here, 11, 10, 9, and 8. And then we're gonna multiply these all together. But since we're sorting 4 things, we're gonna divide by 4 factorial. So all of this divided by 4 factorial. And what we'll get is we're gonna get 990. So there are 990 ways to pick 4 of them from 11, but there's actually like a formula to do this. And so here, this is what I'm going to do. So I'm going to write the formula. So the formula here is going to be, so we have 11, right? So we basically have the 11 factorial thing. So since 11's n here, I'll just write this again. Since 11's n here, we're going to write it as n factorial. And we're also going to divide it by the factorial of n minus k. So since we're picking 4 from 11, this would be dividing by 7 factorial, which is also why we only have 4 spots. But also order doesn't matter here. So we're going to divide it by k factorial, since we're going to divide it by the number of ways we can order those k items. So this is basically the formula, right? And so now I'm going to use the formula. So picking 4 from 11 is going to be a lot easier now. So now I'm just going to write it as 11 factorial over 7 factorial times 4 factorial. And you can probably do this really quickly. You'll get 990. So yeah, that's the answer for 4 from 11 using the formula. So I have some pretty quick formula questions here. I'll give you a few moments to do this one.
I have a question. So find 5 space 3 in parentheses. What is that?
Oh no, it's just that I didn't know how to format those things on the slide, so I'll just rewrite all of these. So it's supposed to be like this.
Okay, that makes sense. So do you use latex? Because I'm pretty sure that would help.
LaTeX, what's that?
Latex is like how to write math things. Like, yeah, I'll chat you how to write 1 in latex. You just put $signs around a number if it's like a regular number, an integer, and you put like and like for latex, well, you can write a lot of things for fractions. Like you just write some things for fractions. It's a little complicated, but LaTeX like makes writing math more clear. Like instead of the 5 and dash 3, it will write it as 5/3 and like that. But then like some websites might, like Google might not have LaTeX.
Oh, all right. So I
Okay,
think I
yeah.
might use that next time.
Okay, everybody's chatting LaTeX.
Yeah, okay, I got it. I'll use it next time.
Okay. LaTeX is actually spelled like L, uppercase L, lowercase a, uppercase T, lowercase e, and uppercase X.
Yeah, I think a lot of people chatted the spelling to me, so yeah, I know how to spell it now. Thanks. All right, I'm going to go over these ones now. So basically we're gonna do, so first problem, choose 3 from 5. So here we're just gonna use the formula. So here we're gonna use the formula. So we have n on the top and k on the bottom. So our formula is n factorial over n minus k factorial times k factorial. But so we can rewrite this as 5 factorial over 5 minus 3 factorial plus, no, times 3 factorial. And we'll get 5 times 4 times 3 times 2 times 1 over 2 times 3 times 2. So we can just cancel the stuff out like this. And what we'll have left is 5 times 2, which is 10. So yeah, that's how you use the formula to do the combinations and computations. So now I'll do the second one. The second one is choose 2 from 9. So what I'm going to do is 9 factorial over 7 factorial times 2 factorial. And that'll get us 36. And choose 7 from 9. So that'll also be 9 factorial 2 times 7, which is 36. And that's the thing. As you can see, choose 2 from 9 and choose 7 from 9 is the same, because basically you're just like, if you choose 2, you're choosing 2. If you're choosing 7, you're leaving 2 that are not chosen. So basically you're choosing the ones that aren't chosen. So those are going to be the same amount. And now we have choose 3 from 60. So this one takes a lot longer, but we're just basically doing the same thing. We have 60 factorial over 57 factorial times 3 factorial, and that gets us 34,220. All right, I have some more little practice problems. So, oh yeah, so I'll just explain the choosing what's not chosen thing. So if we choose 2 from 9, I'll just draw like 9 here. So we're just choosing 2 of these random ones, right? So like we just choose these. And these are like the ways you can choose 2 out of them. But here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. If we're choosing 7, we can just do the 7 here. But the thing is, we have these 2 that aren't chosen, and we can like choose the ones that are left blank instead of the ones that we are actually shading. So it's going to end up being the same amount of possibilities as it's going to be the same amount of possibilities as choosing 2. So choosing 2 and choosing 7 are going to be the same. So I have some more practice problems, and you can do these real quick. If you guys have any questions, you can always chat me or on. Oh yeah, also these are supposed to be special cases. So yeah. All right, so these 3 should be pretty simple. So the first one, what is I'll just rewrite this. What is choose 0 from n for any positive integer n? So we're basically just doing the choosing thing again, except this time we're not choosing anything. So like we just have 0 things we can choose from, right? So we just have 0. And then there would only be one way to choose 0 things. So yeah, that's how choosing 0 from n is. And the second one, what is choosing 1 from n? So basically if we have 1 from n, we will just choose that one. So it's like n n minus 1 factorial times 1 factorial, and that will just leave n. So basically if you choose 1 from n, there will only be n possibilities, since you could just choose, like if you had 3 of them, there's only 3 things to choose from. And the last one, what is n for any positive integer? So in here, we're basically only picking all of them. So if we have 3 things, we'll just pick all 3 of them. There's only one way to do this, since there aren't really any other ways of picking all of them. So that would be 1. So these are like 3 special sorts of cases. You won't really need to know them in like competitive math, but it's just good to know these. So I have some more exercise that I want you guys to do. There's like a similarity between these two, and I want you guys to find it. So I'll give you like 2 minutes to find it out. All right, so here we're going to do these. So here we have we're going to choose 2 from 6. So we use the formula again. 6 factorial over 2 times 4, and this would be 15. Now choose 4 from 6. So here we just do the same thing, 15. And the thing you notice is that these two are the same. As you can see, 2 and 4 add together to make 6. So that means that if you choose 2 from 6 versus if you choose 4 from 6, it's going to be the same. So the rule is if you choose k from n, then that would be equal to if you choose n minus k from n. So yeah, this is the general rule. If you use this, you can make life a lot easier. Like you can choose 2 from 9 instead of 7 from 9. So like this would be something that would be good to know in the future. So I have 2 more exercises that I want you guys to do. So I'll just give you a few minutes because you're basically really good at this already. So I'll just give you a bit of time to do this. All right, so these two are going to be really easy problems, so I'll go over them right now. So for the first one, choose 3 from 8. What is choose 5 from 8? So first we're going to choose 3 from 8. We're going to use the formula. And then I'm going to write this out. It's 8 times. So it's 8 times 7, which is 56. Now, what is choose 5 from 8? Again, this is going to be the same thing. Since 5 is 8 minus 3, it's going to have the same amount of possibilities. So choose 5 from 8 is also going to be 56. And now we're going to choose 4 from 10. What is choose 6 from 10? Again, you know these are going to be the same thing because 6 is 10 minus 4. These are going to have the same amount of choices. So I'll just find one. If you only find one of these, you can immediately have the answer to the other one. So here we're going to do this. 10 factorial over 6 factorial times 4 factorial. And what we have is 10 times 9 times 8 times 7 over 4 times 3 times 2. And this is, we just cancel all this out. And this is going to be 210. And the other one is also going to be equal to it. So now we're going to move down here. So this is the general rule of thumb for computations. The one I told you is easier to know. So n choose r from n is going to be the same as choose n minus r from n, which is really good to know. If you're struggling with the computation, this is always a lot easier to remember, and it's also really good if you want this to solve problems. All right, so now I have some word problems. So these are basically just like regular computation problems, except these are in word form. So once you figure out how to do the problem, it's really easy to solve it. All right, I'll go over these ones. So these are the same concepts as the computations, but like these are just in word form, so you need to understand the meaning of these. So my soccer team has 16 players. I have to choose a starting lineup of a goalie, which only one person on the team can be, and also 10 regular players. So how many different starting lineups can I choose? So firstly, we're going to deal with the restriction, which is the goalie. So since there's only one person which has to be the goalie, it's going to take one from the team. So we're just gonna, so now we only have 15 normal players left, and we have 10 people for the lineup. So now what we do is we're going to choose 10 from 15. So 15 factorial, 10 factorial, 5 factorial. And that's going to be, that is going to be, we're just gonna draw it like 15 times 14 times 13 times 12 times 11 over 5 times 4 times 3 times 2. And what you're going to get is, well, we'll just cancel these out. 7 times 13 times 3 times 11. And that is 270. Just 3003. Yeah, that's the answer. And the second one is I need to form 2 teams of 5 from 10 people. How many ways can I do it? So this one is basically the same concept, except that thing where there's just an additional team. So we're still choosing 5 from 10, except the ones that aren't chosen are going to form their own team. Now, for the first one, the goalie can only be one person. So there's just one specific person. You don't have to multiply it by 16. For the second one, we're just choosing 5 from 10. So 10, 5. And then you get 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2. So we can cancel this out. And we'll get 252. So the answer to the second one is 252. And guys, if you're spamming in chat, please stop, because there are people that want to pay attention and you're ruining it for them. So please stop. So the summary of this whole unit is that choosing a committee means that we're choosing some amount of items from a group, but order doesn't matter. So basically it's permutations, but without orders, and you can just use the format for all, you can just use the format, the equation, the formula for all of these. So I have some more info with combinations here. So basically, you can count the number of ways to choose R items from N, but you can also use this along with the ones we learned earlier, like permutations. We can use these with restrictions. You can use this with complementary counting, and so on and so forth. So now we're going to learn paths on a grid. So we can use these to count the number of paths to go up on a grid. So each block shown is 1 unit by 1 unit. How many paths can we take from the lower left corner to the upper right if we had to stay on the grid that can only go up and right? So here's the thing, since we're going from this corner to the other one, we're basically like choosing random paths up and right to get there. So if you see this, you can see there's 4 blocks right. We'll end up going 4 blocks right and 3 blocks up. And so basically that's choosing, so if we had to walk 7 blocks either way, right? And so we're choosing 3 of these blocks to be upwards and 4 of these to be rightwards. So we're just choosing 3 from 7. So 7, 3, 4. And what we're going to get is 35. So there are 35 paths to get from the lower left to the upper right. So now I have some practice problems. I'll give you guys a few moments to do these. So probability, this is going to be useful. This class is for learning about competition math. So if you learn this stuff, you can do better in competition math, and that can help with your resume, and then you can go to a good college and get a good job. And that's probably the reason why a lot of you are taking this class right now. But some of you really enjoy math, and that's good. But like probability is going to be useful in math competitions. So like that's the reason why you would want to learn it if you're here right now.
I guess we can't count all of these paths up because would take a long time.
Yeah, you can't count them manually, but there are ways to calculate them.
Okay.
All right, so I'll go over these right now. These are relatively easy once you understand them. So first, we need to know how many blocks you have to end up walking to get to the end. So for the first one, we're going to walk 11 blocks to get to the end, like that. And so there are 5 up blocks and 6 right blocks. So we're basically picking 5 of them to be up. So we're just doing 11 factorial over 5 factorial times 6 factorial. which is 11 times 10 times 9 times 8 times 7, 5 times 4 times 3 times 2. And we'll cancel these out. And what we'll get is just 462. Now for the second one, we're going to do the same thing, except this time we're walking 12 blocks, and 4 of these are up. So we can pick 4 out of 12 to be up blocks. So we're just going to pick 4 from 12. 12 factorial, 8 factorial times 4 factorial. 12 times 11 times 10 times 9 over 4 times 3 times 2 times 1. And that is going to be 495. So yeah, that's basically how you do it. And now I'm going to move to the next one. Actually, yeah. So more committee type word problems. This is going to be the last thing I'll have you guys do. So these are basically just word problems, but with restrictions. So like what you do is you deal with the restrictions first, and then you calculate the rest of the stuff. So I'll just give you guys some time to do these, and if you don't get it, you can unmute or you can chat me. You can private chat me. So basically these things we learned here, it's like, well, it's pretty common in like the AMC 10 and stuff. You're going to have to learn how to choose groups from, but you're going to have to learn how to choose from like a set of things. And all these word problems are like the type of thing that show up on the AMC and also other math competitions. So you're going to need to learn this as well. All right, I'll go over these now. So these are like the same concept as these are the same concept as the all the problems we did previously, but you have to understand, and also there are restrictions. So Coach Ron, can you unmute? Can you mute because the echo? So yeah. Coach Grunt is preparing the 5-person starting lineup, blah blah blah, and the special restriction is 2 people hate each other, and they can't serve at the same time. So here we're gonna choose 5 from 12 as the initial lineup. So we're gonna do this. And what we get is 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2. So we're just gonna do this real quickly. Yeah. And what we're just gonna find the stuff out. And we are going to get 11 times 9 times 8, which is 792, which is the initial number, but that's not our final answer because now we need to deal with the restriction. So we know that these two hate each other and won't serve together. So we have to find all the possibilities where they are together on the team. So we have these two guys, A and B, and we just have 3 spots, and we're also gonna have 10 other people. We're gonna have 10 other people to choose from besides A and B. So basically we're just choosing 3 from 10 to fill up these last 3 spots. So we have 10 factorial times 3 factorial times 7 factorial. And we get 10 times 9 times 8 over 3 times 2. So we do this, and we'll get 40 for all the possibilities where these two serve together. So now we're just
Wait. When you do like 10 times 9 times 8, is that all you do? I thought you had to go beyond that to like 7, 6, 5.
oh no,
all
we
the way
had
down.
the 765, but that cancels out with the 7 factorial that we already divided by.
Oh, I see what you mean.
Yeah, so we just have 40 left. Now we subtract all the possibilities where they all serve together, and the final answer is 752. And for the second one, there are 30 men and 40 women in the library. They want to form a committee with 3 men and 4 women. How many ways can they do this? So we have the 3 men and the 4 women. So first we pick 3 from 30 for the men. So we do 30 factorial over 27 factorial times 3 factorial. And we get 30 times 29 times 28 over 3 times 2. We cancel all this stuff out, and just give me a sec to find out what this is. And what we get is 4060. And now we need to choose 4 from 40 for the women. So 40 factorial over 36 factorial times 4 factorial. And we're going to get 40 times 39 times 38 times 37 over 4 times 3 times 2. And we do get is, which is 91,390. And now we multiply the number of possibilities for the men and the number of possibilities for the women together. And now we got this huge number, 3710433400.
I thought we were supposed to like add them together.
No, we don't add them since like if you have one permutation of men, you still have like 91,000 women. So like there's going to be that much for each possibility of men, so we have to multiply them. So yeah, this is our final answer. I'll give
Wow.
okay, so homework is gonna be out in the next few days. I'll see you next week. Bye.
Bye.
I thank you.
Thank you.
Bye.
Bye.